Hi, welcome to another JavaScript class. In today's lesson, we will be discussing data structure and algorithms. Data structure and algorithms are the backbone of programming. They provide the fundamental tools and concepts for organizing, storing, and manipulating data effectively, as well as designing algorithms that solve complex problems. Understanding data structure and algorithms is essential for anyone involved in software development field, as they play a crucial role in writing effective and efficient code. Let's get the definition of these two guys out of the way so we can jump into the code. Data structure are ways of organizing and storing data in a computer memory or storage. They provide a framework for representing and manipulating data in a structured manner. Different data structures are designed to optimize various types of operations such as insertion, deletion, searching, and sorting. Common data structures include array, linked list, stack, query, trees, graphs, and hash table. For your level, we will only be focusing on array data type because it has quite a lot of flexibility and generalization. In JavaScript, arrays are versatile and commonly used data structures for storing collection of elements. They can hold values of any data type, including numbers, string, objects, and even other arrays. Here's how JavaScript array works. So let's start by declaring an array, and we are already used to this. So this is how we declare and initialize an array. But what we need to also understand is how does array store information in the memory? How is it stored and how is it accessed? I'm going to put something out here that talks about the array length. And that can be counted like say 1, 2, 3, and 4. Array length is counted starting from 1 to the maximum, which is 4. In this case of our example, it is 4. The next thing that we have that we need to also understand is array index. Array index is how you access the value of the array in memory. So the index starts from 0, which is kind of weird, but that's how it works. So index in most programming language starts from 0. So what we have on top is the length, and at the bottom we have the array index. How do you access an element within an array? Array elements can be accessed using their indices. So for instance now, to access BMW, we need to get the array name, which is my array, and access it using the bracket sign and 0 inside it because we want to access the BMW side. So just to give it a test to see how the index is being accessed, we do log. To access BMW, we use the index to access it, and the index here says 0. So if we run this, we can see that you are getting BMW as an output for accessing 1. If you want to get Ford, it means you have to use 3 to get to it. If you use this, you are getting to the Ford item. The next part you need to also be familiar about is how do you get the length? How do you get the length of the array? Because this array can grow for all we know. This array can grow, and when it grows, you need to be able to know the length of the array dynamically without you counting, because you won't be able to count. So how do you get to know the number, the length of the variable? Array has a property that is called length that will allow you to figure out the length of the array. So let me just print this out in our fancy way. So if we run this, we should see something similar to this. My array has a length of 5. As you delete or as you update the array information, what then happened to your result, you then have return a property of the length, which will always be updated for you to see. So moving on, we've been able to see how to access it, and we've been able to see how to find the length. The next thing we want to figure out is how to iterate through the array, like how to go through each of the array and figure out what is happening with them. Because it's possible that you want to do some computation on each of these items. Let's say you want to write a report and you want to say the car drive is BMW, the car drive is Honda, the car drive is Toyota. You want to do something like that. So you want to be able to go through each of these data one after the other automatically without doing it manually like this. Because this is doing it manually, you specifying each of the elements is doing it manually. So if you run this, fine, you are able to get the data manually, but you should have a way to go through them automatically in such a way that you have all these items listed. And you guessed it, we already have done something like that before using the for in. But this time around, we want to use another method, which is the for loop method, and use the fact that we have the length in place. So we're going to be using some couple of methods to iterate through the array. So first of all, we'll be using our for loop that will require us to define our counter. We initialize it to be 0, and then what are we spanning it to? What is the maximum that we need to go? Know that now we now have the length of the array. So you can do when I is less than my array dot length. So we can then do our data incremental, and you can print to the console what each of the item is by using I, your counter, as an index. So because your I will start from 0 automatically till it gets to the length, and once it gets that, it will print out this result. So let's give it a test. So you can see that you have your item all printed out here. So we can say BMW is in index I. So when you run that, you have this beautiful output. BMW is in index 0, Honda is in index 1, Toyota is in index 2, like that. And that validates what we talked about here, the graph that we just done here. The next form of iterator that we have is the for each. So the for each is attached to the array itself. It's a member function of the array. So how do you use that? So you use it by specifying the array and using your dot notation. Immediately you do your dot notation, you search for the for each. The for each comes out and it requires you to pass a callback function. This is new. Callback function is new. What is callback function? Is a function that has no name. That's the easiest way for me to explain it to you guys. It's a callback function that has no name. What does that mean? How does your normal function looks like? You have your normal function that looks like this, function name, and you have your code block. My definition says is a function that has no name. So if it has no name, then this is what our callback function should look like. So I'll put all my code, what is here, inside this section. So look at it. What has just been extracted here is the fact that I removed name out of it. This is a function inside a parameter here. A function is being passed as a parameter into the for each. The next thing that we need to do is that your callback function for your for each method requires two parameters. The first parameter is the item in the array, which is here, the item, and the second parameter is the index, because those are the two things that is going on in your array. That's the value and the index. So the first thing you want to provide is you can say value, and this is any variable. You can call it anything you want. So I will just say value and index. So when you do that, you can then write the body of what you want to happen to each of the item. So what I want to do, I just want to print out everything that is happening on the item. So I can repeat the same code here. I said my value, which is going to be either Honda, Toyota, or Ford. I can just put that information there and say value. And my index, which is going to be either 0, 1, 2, 3, or 4, I can just represent it as normal index. And the reason why I'm writing index of value is based on the argument that, or the parameter that I've specified here. Any parameter that you make use of here is what you're going to be using in the code base. So let's run it and see our result. So when we run this, you can see your result comes like the same thing you did with for loop. So the for loop works well, the for each is also doing the same. So this is giving you an extra flexibility if you want to use your array to go through it. So you can see the difference you have in both. The difference is that this one uses a callback function and you have your value and index being on their own. You don't need to do this insertion to get each of the item. It's not enough that we can look through it or we can get an item that we want in the array. How do we then delete item? For example, how do we add item? Because these items are not supposed to be constant like this. They are supposed to be dynamic in such a way that users are supposed to be able to add to this list or remove from this list. So that brings us with the manipulation of data in array. We start with pop. So pop is to delete. So pop is to delete the last item in an array. And how do you get to use it? Straightforward. You just call the array using the array and call the pop function. So once you call the pop function, what do you think? It will delete the last item you have in your array. And then we can always check it out here. So whenever we call any of the function, we will check it out to see the new result of our array. We can just console log this and say we want to see what happened after we pop the array. So after pop, let's see what happened. So when we pop the array, it removed the last item. What is the last item? Is RAV4. That's what pop is used for. It's used to remove the last item. Then let's look at the next thing we have on our table. And the next thing is push. So if pop is to remove, push is to add. So push add item to the end of the array. Of course, so let's go ahead and try this out. Push. So what do we want to push to this array now? So let's push another kind of vehicle. Let's push Jaguar to this array, and let's say after push, and see what happens after push. So when we run that, we can see our result that has BMW, Honda, Toyota, Ford, Jaguar after we pushed. The next example we have is unshift. Unshift adds item to the beginning of the array. Let's give it a try and see what we'll have. So if I just duplicate this, of course, the only thing I'm changing is the function name. The function name now is unshift. What do I want to add? Genesis. Then I can say after unshift. So if you run this, we have the results. So you can see that Genesis has been added to the list of array. Now we now have 1, 2, 3, 4, 5, 6. In fact, we now have 6 items in the array. So the question might arise, how do you delete an item? Because we've used the word pop and to remove the last item. We can also use the word shift to remove first item. But let's say we want to remove Toyota, for example, from this list. It looks as if it's not, feasible to do that. You just need to use some of the functions that the array provides to do that. And that function is called splice. What splice does is allow you to extract some portion of the array and then use it to create a new array. So let's go ahead and give that a test to see. So we'll be using the splice. So that's to extract new array from the current array structure. Let's go ahead and give it a try. So we'll have your array, then you run your splice. Before we run, we'll log as well. We'll say after splice. Remember what we want to do, we want to remove the Toyota from the list. So splice allow you to pass 2 parameters, and we're going to explain those parameters because those parameters are what makes the magic work. The first parameter that the splice required is where are you starting the extraction from? Which element do you want to remove? Is Toyota, right? We know that it's Toyota we want to remove, but what is the index of Toyota in the grand scheme of things? Remember, our index starts from 0. So we have to start from Genesis is 0, BMW is 1, Honda is 2, Toyota happens to be 3. So we are starting our count from 3, meaning that you want to remove Toyota till where? You don't want to remove Ford with it, you don't want to remove Jaguar with it. It's just Toyota you want to remove. Since you are specific on removing Toyota, so the next parameter is the fact that you are removing 1. So that's delete count. How many items do you want to delete with it? So we're already deleting 1. So if I specify that way, we've been able to remove Toyota from our list. That gives us a new item after this splice. So the splice that we run to remove Honda was this. So we do splice 3,1 because of the position of the item that we want. So again, you can remove 2 items. It might not just be only 1 item you want to remove. So if I run this again, let me uncomment this and let's change what we want to remove this time around. This time around, we want to remove 2 items, and we want to remove, let's go the other way around. We want to remove BMW and Honda together. So where does BMW start from? It starts from 1 because Genesis is 0, BMW is 1, so it starts from 1. So we want to remove BMW and Honda together. So those are 2 items. So it says splice 1, 2, 1, 2. So if you run this, you shouldn't see BMW and Honda anymore in our new result. So our new result feature Genesis, Toyota, Ford, Jaguar. And then that's how splice work. It's very great for removing item because the pop and the shift allow you to remove the first and the last. The splice allow you to pinpoint what you want to remove in your list. function we want to go to is index.of. As you can see, the index is very important to doing a lot of things in array. The index is what determines how we get the value. So it means that index must be important. So how do you find the index of a particular value so that you can manipulate the data along what you are doing? And we use the method called index.of. Let's say we have, maybe we want to do index of item. We want to create a variable and we have our array is already defined, and I want to find the index of Ford. What is the index of Ford? For a reason, because I want to manipulate it. I want to do something to it. It's possible that you want to delete Ford, because this is another way for you to delete an item. You can find the index and then you delete the index using splice as well. So if I do index.of, if you look at our code on the bottom, our index should be 2. Ford index is, so we should be expecting to see 2 as our result there. So if I dump out this variable, we should be seeing 2 as our index of Ford. So our definition of array was not correct. Our variable does not exist. So let's run that again. So you can see that Ford index is 2, and then use this to do quite a lot of computation. Knowing the index, you can go ahead and say, oh, okay, you want to remove Ford. You can go ahead and remove Ford by using this splice. So let's go ahead and remove Ford. And how do you then execute that? Using the splice information, you then say you want to start from where you are starting from index of Ford, which is here. And of course, you want to remove one item, and I can properly define this and say index of Ford. So that way it's spelled out and you know that you are capturing the index of Ford. Then because it's one item you want to remove, and you can come here and see our results after we do this. So let's run our code and see the result. So you can see that Ford has been removed successfully from our list because we were able to find the index and remove it. So this is you using index.of. If you know the item name, for example, and you want to remove the item because you know the item, you know that there's Ford in the list and you want to remove only Ford, we run this line of code, which is line 39, to find the index, and we can then run line 42 to remove the index. And by the way, we'll be doing actual code down the line in the course of this program, and we'll be doing to-do lists. We'll be using all this feature to delete item from your list and to add new item into your list. So this is a kind of showing you what the function is all about, so that by the time we're using the functions, they are not strange to you anymore. It's time to start solving problems. Algorithms, on the other hand, are step-by-step procedures or sets of instructions for solving specific problems. They are a sequence of well-defined actions that transform input data into an output result. Algorithms are essentially for solving a wide range of computational problems, from simple tasks like sorting a list of numbers to complex tasks like searching for patterns in large data sets or training machine language model. In addition to our definition, an algorithm must be finite, well-defined, and efficient in carrying out the set operations. So the big question here is, how do you then write an algorithm? This happens to be one of the biggest challenge of many programmers. I'm going to try as much as possible to break it down step by step. 1. Understanding the problem. Before you start writing an algorithm, make sure you thoroughly understand the problem you are trying to solve. Define the problem statements, understand the inputs and desired outputs, and identify any constraint or requirement that you need to get all these things to work. 2. Plan your pseudocode. Pseudocode is a high-level description of your algorithm using a mixture of natural language and simple code-like syntax. It is a way to outline your algorithm logic before getting into the detail of actual programming. Write down the steps you think the algorithm should take in plain English. Keep it abstract and focus on the logic, not exact code. You don't need to write the exact syntax. This way, you are more focused on putting out the idea first and not carried away about the magnitude of the problem. 3. Break down the problem. Divide the problem into smaller sub-problems or tasks. Each step in your algorithm should be simple and well-defined. The process of breaking down the problem makes the algorithm more manageable and easier to understand by anybody reviewing it. 4. Data structure. So you can see where data structure comes in now. Determine what data structure, is it array, list, tree, etc. you will be using to store or manipulate the data within your algorithm. Choose the appropriate data structure based on the requirements of the problem. 5. Define variables. If needed, define the variables that will be used to hold and manipulate data during the algorithm execution. Assign initialize variable as necessary. 6. Write the steps. Remember the pseudocode you plan in step 2. Now, start converting your pseudocode into actual codes. Write down each step of the algorithm in the programming language of your choice. In this case, we're going to be using JavaScript for our own example. Use the loop, conditional statements, and other programming constructs to implement the logic you have outlined. 7. Test your algorithm. After writing your algorithm, test it with various inputs to ensure it produces the correct output. Test it with both typical and edge cases inputs to validate its functionality. 8. Optimize if necessary. If your algorithm isn't performing as efficient as desired, consider ways to optimize it. This might involve changing the data structure, adjusting the logic, or finding algorithms with better time and space complexity. Remember that writing a good algorithm often involves iteration and refinement. You might need to revisit and modify your algorithm as you gain a better understanding of the problem or receive feedback from the people testing your code. With practice, you will become better at breaking down problems and creating efficient algorithms. So I'll be giving you guys a lot of assignments that will help you to prepare yourself for writing more algorithms. It's time to start solving problems. First problem that we have here, and we're supposed to be able to write an algorithm that will be able to search any of the value. So that is our problem. And if I give this to you to do as a person, that I say I have 11 here, and I ask you to search for 11, how will you do it? There are several ways in which you will try and solve this problem, and that will be checking one after the other. You check the first item, you check the second item, you keep checking until you exhaust your results, and then you eventually finally find your result. This is one algorithm, and which we are going to write the code for it. There are several algorithms in which will eventually make you search for your result faster, as the case may be. These are topics that are very wild, and the purpose of this course is to show you how to write an algorithm, not really on how to repeat what has already been done before. So in solving this problem, what we need to do is to follow the steps that we've highlighted before. Starting from the beginning is to understand the problem. We already understand what we want to do. The question is up there is to search and find a result based on if the value is in the array or not. And by default, this is just a value. We are the one that decide that we wanted to use an array, as the case may be. So the next thing for us to do is to define what are the inputs and what is going to be the output. The first input that we need to define is that it's going to accept this information as an array. The array needs to come into the function as an array, and we also need to have another input, which is going to be what we are searching for. The next thing we need to do is to plan our pseudocode. Like we need to write a high level code that will do what it is we want to do. So I'm writing a high level code now that is supposed to look through each item in the array, compare each item in the array with the search value. If it's the same, terminate the search. If not, continue searching. At the end, if no results, report no results. This is our pseudo code that we've written in English. So we're supposed to follow this step. The next step that we have is to break down the problem. We divide the problem into sub problems. This has already been done in this case. Sometimes when you write your pseudo code, it would have already simplified those things that you're talking about. We'll go to step 4, which is data structure. We decide on which data structure we're going to use. By default, we're already using an array. Array is what we're going to use in this case to hold our information. Then we need to write our step in actual code. Now, remember that we're writing a function. A function is what we're writing, and because it's going to be an algorithm, we're creating a function, and that function will be a search. So I'll call it lSearch. Our function is accepting two parameters. It's accepting an array. So our input is going to accept array and is going to accept our search key that we need to supply, because when you provide the data, you need to say, okay, what are you searching for? We provide this data as 1 3 4 5 6 7 7 10 11 2 3 5. You need to tell the system what you are searching for. So we can say we are searching for 7, or whatever it is that you want to search for. That's what the key is supposed to be. And this is identifying, this is in step 1, identifying what your inputs are and your desired output. So our output, you can also say what your output is in terms of it being the result, like found or not found, or found in position this or not found. Those are the things you need to define first as your output. Next thing I want to talk about now is looping through each of the items, because I want to check each of the items, so I should be able to loop through each of the items. So let's go ahead and loop through each of the items. We already have various ways in which we can loop. Let me use the new thing that we have, which is the for loop. I have my array, because my array would have come in here, and then I can do my for each. And your for each is defined this way: a function without name inside your bracket, because your for each is supposed to accept a parameter. So inside your for each, it will be a callback function. A callback function does not have a name, so you go for function. Instead of you to put the name of the function, you just put your bracket there and you write your code block. But the thing about this function is that it accepts 2 parameters. It accepts the value and the index. So when the each is happening, what you want to happen will happen inside line 15. So what is the next thing that we're supposed to do? We're supposed to compare each item in the array with the search key. How do you compare? You do an if condition. So we write our if condition. If your key is equal to what is the value, you want to return something that say found, so you want to return that. So you need to declare what it is you are returning. So let's create our results. Let's define our results. Let results, you can either equate to something or you leave it blank. And then we can come here at the end of everything. We are returning our results. We're just preparing for our results. If it found something here, it means item found at. By the way, this code we're writing is just a sample. You see how we're going to refine it, because it's part of the process. You can write your code and later you can keep refining it to make it faster and execute better. Of course, there are errors in this code. I don't want to address those errors. I just wanted to see what happened and how to treat things as they occur. Let's now execute this out. We are searching for the array, which is this one. And what are we searching for now? You're now searching for 77. In part of the steps you are supposed to take, you are supposed to test your system very well, put values into it, check it for edge scenarios to make sure that it can withstand the test of time and whatnot. Our output is equal to this, so that we can console log our output. So let's give it a try. Item found at index 5. So this worked great. Let's try to search for 1 and see what it says. Of course, it found it on index 0. If you try to search for 6, and it found it on index 4. Let's try something that is not in the list, which is 65, and see what it says. It says undefined. I purposely did this so that you are going to see how things transpired and how you can execute code like this to give you results that you want. By default, your let result is what is undefined. So if this code executes line 7 to 11 execute without finding a result, it's going to return undefined. So what you can do is find your result to be blank, or by default, or to be saying not found. So your result can just be not found by default. And your not found will change only if something happens here, which is line 9. If line 8 to line 10 is true, that's only when we will have this change from not found to item found at index what. So let's run it again now, and then you can see a different result saying not found, because now you've initialized your result. If there is an item there, let's go to 77 now. If you now have an item, it will give you this in your result. Another thing you need to also figure out that was going to be a problem, this one is now going to be like efficiency, because the idea of an algorithm is that after you must have written it, you have to keep tweaking it to make it very efficient in such a way that it can be optimized and run very fast. It's at the point that what happened when you see your result at 77. Do you notice that the system keeps searching for the rest? Because this is how to prove that the system is still searching even after it has found the item. So if it has found the item, I'm going to say found. So I'm going to say found here, and I'm going to show you that it's still searching here, but still searching. Searching where? I'm searching index, so. But still searching 0, but still searching 1, but still searching 2, searching 3, searching 4. Found at 5, but still searching 5, but still searching 6, but still searching 7. So we've wasted time doing all this, which is not necessary. So if you've searched and found a result, what do you need to do? You can exit the loop and go out, because you are done with your search criteria. So you don't necessarily need to do any other thing again. You can exit the loop. So one of the ways for you to break out of this is to modify the array length, because this array length is running to the entirety of what is provided, which is in this case, I think it's running up to 9, which is 10. So how do you break off of this? Because at this point that you found your result, you want it to stop. So this is refining your code. And the way to do this is to adjust the length of the array itself. The length of the array, you want to make it to the index, so that way it terminates at that point. So if you try and run it again now, you see that it's still searching 0, still searching 1, still searching 2. Once it gets to 5 and it found it, it assigned the length of the array to the current index, and it doesn't need to go further again. It stops at that point. And this makes your code very efficient and very fast. So it doesn't need to start searching through all the needless value again. If we're looking for 1 and immediately it sees 1, it doesn't need to go and search the rest. It finds at index 0 and is fine with it, and your code is fast and efficient. Example number 2 that we want to treat now is sorting. So we have another example we want to do, and this time around it's going to be sorting. So write an algorithm to sort a number, a list of numbers. So let's just say, for example, we have list of number that is in this form, and we're supposed to write an algorithm to sort them out. So here you could use several methods. You could say, I want to use bubble sort. By the way, the idea of bubble sort is that it compares the first value you have versus the second value, and it checks both of them. Whichever one is smaller, it puts it to the left, and then the bigger one goes to the right. And you continue this until you finish passing through the list of array. And you need to continue this until all items are sorted. When you notice that there's no more item, lower than the one on the right, then it gives up and say, okay, you've completed your loop. What are going to be the inputs? Our input is going to be our array itself, is going to be our input. Then what is going to be our output is going to be our sorted results. So what's going to be the procedure? We're going to compare loop through array and compare the first with the second. If the second is lower, swap, else ignore. Once there is nothing to swap, it terminates. So this is what we want to write now. Let's go ahead and write our function as sort, and we require an array. So we can use our for loop. Of course, you're going to be looping through what you have there. We can start with I is equal to 0, and your array, I is less than your array. Inside it, you need to also check, because this is the first item. This first one serves as the first item that you're looking through. And the second one is going to be our j, by j equal to 0. Okay, so this is where we need to start doing our if and be checking what's going on. So we do our if array of j, that is the one that we're inside, is greater than array of j plus I, which will go a step, that's to find the adjacent j plus I. That will give us the adjacent. What then happens if that value is bigger than what it is? Then we can do a swap, and we can say swap the position. So to swap the position, we need a temp variable to hold the item in place. So which is this item we're going to put here. We need to hold this item in place because we want to swap the position. So the variable needs to be held somewhere such that we can then have this value change here of j to become what j plus 1 is. So this case, we can then update the value of j+1 to be what is in the temp location. So this is how you implement a swap, variable swap, because you are updating the same array variable. So you have to be careful here. First of all, the variable goes into a holding position, which is the temp here, and it's getting replaced here, which is your array is then replaced with this one. We still have the original location of what your j is. And now that you are ready to switch your j+1, we could then put your temp inside here. So it updates the position of your array. So once you are done, we can then return everything here. Let's execute this and see what we have if this works. I'll come here to bring our execution here. Let's do our output and sort. So finally we can do console log. Let's try it again. Okay, so we are good. We didn't add semicolon there. Okay, on running this, we have our file sorted correctly, and you can try as many examples as you want, so it will all work well. And this is what you call bubble sort. So anyhow you do it, it will always sort these results for you. So that is the work of an algorithm. When you have a problem out there, you are supposed to break it down to the simplest task, and you're supposed to execute it based on the fact that you know conditional statements, you know how to loop, you know how to use the array as a data structure. So array is a very complex and very important data structure that you need to familiarize yourself with and be able to use. The assignment for this week is to fine-tune the bubble sort and make it more efficient. Thank you for staying to the end. I hope you enjoyed this video. Don't forget to like, share, subscribe, and turn on bell notification in order to be notified when we release new videos. See you in the next one.